Oh no, we have a word problem! Before you freak out, think about what we do in class with our GFK sheets that you guys love. I want to write down what I'm given. I want to write down what it is that the question is asking me to find out, and then I'm going to figure out what I know that's going to help me solve this problem. First thing I'm going to do is read this question. And I'm going to underline what's important. A cylindrical child's wading pool, it's like a swimming pool, has a diameter of 10 feet and is 18 inches deep. I'm noticing, two different units. How many gallons of water can the pool hold? How much does the swimming pool weigh when full of water? Round your answer to the nearest tenth of a gallon. And then I notice that there's some bold-faced information up here that's giving me some information about how much water weighs. And then how many gallons a cubic foot of water is. Okay, so first thing I'm going to do is draw a picture. So, you know what a cylinder looks like. Not like that. Okay, so I have like a little baby pool. Fun. A cylindrical child's wading pool has a diameter of 10 feet. So I know if the diameter is 10 feet, then the radius of this pool is 5 feet, because radius is half the diameter. And it's 18 inches deep. So I'm thinking that I need to get this problem into either feet or inches in order to find the volume. And what's going to help me make this decision is what I'm ultimately being asked to find. I want to find how many gallons of water the pool can hold and how much the swimming pool weighs when it's full of water. And I notice up here that the conversions they give me for gallons and then for weight are converted from cubic feet. A cubic foot of water is 7.5 gallons. A cubic foot of water weighs 63 pounds. So I probably want to get or convert this figure right here, this inches, to feet. You might be able to do this in your head, but the way we practice in class was like this. I have 18 inches. I want to multiply this by the conversion factor that relates inches and feet in order to get my answer in feet. I want to go from inches to feet. I'm multiplying 18 inches by some value of 1. It's going to get me feet. So I'm thinking, how are inches and feet related? Well, there's 12 inches in a single foot. Am I going to write this as 12 inches over 1 foot or 1 foot divided by 12 inches? And I'm thinking, well, if I want my inches to cancel out, I probably want to put inches on the bottom. So I'm going to multiply 18 inches, by the conversion factor, 1 foot divided by 12 inches. I'm multiplying this value by 1. It's not changing this value. What it's allowing me to do is cancel out my inches. I have an inch divided by an inch. Anything divided by itself equals 1. Multiply across. 18 times 1 is 18. That value divided by 12 is 1.5, 1.5 feet. Not 1.6 feet. Okay, I might have 1 foot 6 inches, but 6 inches is half a foot, and 0.5 is half of 1, or 1 foot. So 1.5 feet. So I'm going to say that my 18 inches is 1.5 feet. Man, this is kind of a long problem. Bear with me here. So let's first find the volume of this pool. Volume is the area of the base times the height for a two-based figure. My base is a circle. Area of a circle is pi r squared. We're going to multiply this by the height of the pool. I have a radius of 5 feet. I'm squaring that value, and I'm multiplying that by the height of the pool in the same unit, which I just figured out is 1.5 feet. Okay, let's switch colors here. Now I'm just going to figure out all these values. So order of operations, parentheses and exponents. What's within my parentheses is already in its most reduced form. So next I go to exponents. 5 squared is 25. Pi times 25. Ooh, and I'm going to write these in parentheses so I don't get mixed up between the dot as a multiplication and then a dot as a decimal. 1.5 feet. Okay, so 3 sets of parentheses. I'm multiplying all these values. I'm going to use the pi on my calculator to get a decimal answer for this. So pi times 25 times 1.5 gives me an approximate answer of 117 and 81 hundredths. What's my unit? Cubic feet. That's the volume of this pool. That's really cool, but it's not what the question's asking. That was a terrible circle. Okay, whatever. I know that this is the volume of the pool in cubic feet. The question's asking me to find how many gallons of water can the pool hold. So I need to convert this cubic feet to the measurement of gallons. Now I'm told that 1 cubic foot of water, so that's a box essentially measuring 1 foot by 1 foot by 1 foot. Within that box I can fit 7.5 gallons. I'm trying to think if I have a gallon of milk in my fridge. Let me check. Okay, I have half a gallon, but you guys have probably seen like a full gallon of milk. I can fit 7.5 full gallons of milk in a box that measures 1 foot by 1 foot by 1 foot. Bonus question, how many half gallons of milk can you fit in that same box? 15. Okay, but we're only finding gallons, not half gallons. So I'm going to do the same dimensional analysis or unit conversion. I'm going to take 117.81 feet cubed. I need to multiply this by some conversion factor of 1 to get a final answer in gallons. So I need to find this value right here. Okay, so I'm going to think to myself, how are gallons and cubic feet related? Well, it tells me up here. It says a cubic foot of water is about 7.5 gallons. So I'm either going to write 1 foot cubed divided by 7.5 gallons or 7.5 gallons divided by 1 foot cubed. I need to get the units that I want to cancel out in the numerator and denominator so they divide and cancel to 1 or reduce to 1. So that means I need to have feet cubed on the bottom. Okay? So in 1 cubic foot, I have 7.5 gallons. Now I have two fractions. This is technically over 1. Multiply across. 117.81 times 7.5 equals 883. Let's round to the nearest tenth. 883 6/10 of a gallon. Great! Remember, a foot cubed divided by a foot cubed reduces to 1. I answered that part of the question. Now I need to ask myself, how much does the swimming pool weigh? Okay, how heavy is it when it's full of water? So I'm going back here and I'm noticing that this problem is telling me that water weighs 63 pounds per cubic foot. Now what a lot of you did on the assessment, and this is such a good mistake, is you took your gallon amount and you converted from gallons to pounds. And so you went, oh, 883.6 times 63 equals whatever amount of pounds. However, you don't have a gallon of water weighing 63 pounds. You have a cubic foot of water weighing 63 pounds. So we need to go back to using our cubic foot measurement. But now we're going to figure out how many pounds, so how heavy this is, instead of how many gallons is it. So same values before, times what value relating feet cubed and pounds, because I want to find my final answer in pounds. And pounds is abbreviated LBS. You'll see that a lot. Okay, so what's the relationship between pounds and cubic feet? Well, I'm told that there are 63 pounds in 1 cubic foot. So I can either write, well, let's see, what would be the problem with writing 1 foot cubed over 63 pounds? Oh, when I multiply across for my fractions, I would get feet cubed times feet cubed. That would be like feet to the 6th, and I'd still have this pounds here. No. I need to get rid of the feet cubed because the question is asking me to find a measurement in pounds. So let's put feet cubed in the denominator. In 1 cubic foot, so a cubic foot, a box measuring 1 by 1 by 1, how much does that box weigh when it's full of water? Well, 63 pounds is what they're telling me. I now have two fractions. When I multiply across, I get 117.81 times 63. Erase you. Ooh, that's a really big number. 7,422 pounds divided by 1 times 1 is 1. Feet cubed divided by feet cubed reduces to 1. I'm left with the unit pounds. This is so magical. So this swimming pool, not only do we know its volume in cubic feet, we also know how many gallons the pool is and how much the pool weighs. So unless you guys are doing like some heavy lifting at football practice, probably not going to be able to pick up this pool. This is a heavy pool. 7,422 pounds. I can do like those, like, who am I kidding? Like a 5-pound dumbbell? That would be like a lot of dumbbells. I'd have a really hard time lifting up this pool. Also, I'm thinking to myself, 883 gallons. That's a lot of liquid. If I can drink half a gallon of milk for breakfast, I'd have to like eat like 1,600 or 1,700 breakfasts worth of milk to fill this pool. I'm not really making sense, but I'm trying to relate this problem to my life, and this is kind of how my mind works when I'm doing that. I'm way over my time limit for this video. You guys are probably bored, but this is how you would maybe go about solving this problem. Good work.